my dear students. This is Sonia ma'am, and today I have come with one of the most important laws in electricity, that is Kirchhoff's law. Students, you must have heard about Kirchhoff in 11th standard also. Kirchhoff was a very famous German physicist, and he had given his contribution in many aspects of physics like electricity, spectroscopy, and also in black body radiation. In 11th standard you must have studied black body radiation, and one of the laws of black body radiation, that is Kirchhoff's law of black body radiation, is very famous law in black body radiation. So today we are going to study another very important law of Kirchhoff in electricity. So Kirchhoff's law in electricity was proposed by Kirchhoff. His full name is Gustav Robert Kirchhoff, a German physicist. He proposed this law in the year 1842. He was a student when he had proposed this law, and till date we are using this Kirchhoff's law in determining many distributions of current in complex circuits. Even now in electrical engineering, the most fundamental law that is obeyed or followed is Kirchhoff's law in electricity. So let us discuss what is Kirchhoff's law. So Kirchhoff's law of electricity is actually two laws. One first law which is called as the junction rule, and the second law is called as the loop rule. We can call it as the KCL and KVL. KCL full form is Kirchhoff's current law, and KVL, that is the second law, is called the Kirchhoff's voltage law. So let us study one by one. What is Kirchhoff's first law or the junction rule? So students, this law states that whenever there is a junction at any electrical circuit, then the algebraic sum of currents meeting at any junction in an electrical circuit is always zero. That means if I take here a junction, this is an electrical circuit junction, an arbitrary junction where you can see 5 different currents are meeting at this junction. So you can see I1, I2, I3, I4, I5. All these currents when summed up will always be equals to 0. So students, to make this total sum to be 0, we have put some sign conventions. So what are those sign conventions? Always remember, whenever current is meeting or it is towards the junction, it is always considered positive. So the current flowing towards the junction is always positive, and the current flowing away from the junction is taken to be negative. So if I use Kirchhoff's law for this junction, so let me take the currents entering to be positive. So I1, I3 and I4 are positive currents, and I2 and I5 is leaving the junction, that's why they are the negative currents. So here I have put the values here, I1, I3, I4 to be positive and I2 and I5 to be negative, and the total current will always be equals to 0. So if I take the negative ones to the other side, then I1, I3, I4, the algebraic sum of the current entering or towards the junction is always equals to the algebraic sum of the current outgoing or leaving the junction. So the incoming current is always equals to the outgoing current for any junction. So students, here you can see that there is no current accumulation. That means there is no charge accumulation or charge removal. Whatever current is entering, it is flowing out of the junction. That's why this law obeys the law of conservation of charges. So it is in accordance with the law of conservation of charges, and this law is also known as the current law. So Kirchhoff's current law is nothing but Kirchhoff's first law or the junction rule, where the total current at any junction will always be equals to 0. So the algebraic sum of currents meeting at any junction is always equals to 0 in any electrical circuits. So this is one of the most fundamental law in electricity. So let us go to Kirchhoff's second law or the loop rule. So here students, we are with the Kirchhoff's second law or the loop rule. So this law states that in any electrical circuit, you can see an electrical circuit. I will take an example of an electrical circuit, and in any electrical circuit, mind this point that it should be closed loop. the circuit here should be always closed. Then only we can apply Kirchhoff's second law or the loop rule. So in any electrical circuit forming closed loop, the algebraic sum of product of current and resistance in each part of the loop is equals to the algebraic sum of EMFs in that loop. For example, if I take a circuit, there are many cells in the circuit, then the total EMF due to the cells should be equals to the product of current and resistance in that circuit. So let me take a small example, students, and explain it to you. So here I have taken an example, students. There are two loops here. In this circuit, there are two closed loops. So this, let me consider this to be loop 1 and this considered to be loop 2. So in both the loops you can see, student, there are cells and there are resistances. So the total EMF due to the cells should be equals to the product of current and resistance in the cell, the total product of current and resistance in that loop. So let us discuss this later, students, but first we need to know what are the sign conventions and what signs do we use in electrical circuits which obeys Kirchhoff's second law. So let us see the sign convention, students. So here I have taken an EMF of a cell. So here you can see, students, I have taken a direction which is from negative terminal to positive terminal of the cell, or the negative portion to the positive portion of the cell through the cell. So this is inside the cell. The direction I have taken is minus to plus of the cell through the cell. So if my direction, if we traverse along the direction of minus to plus terminal of any cell, then the EMF will always be taken as positive. If we traverse, or if we take a direction which is showing the direction from positive terminal to the negative terminal of the cell through the cell, then that EMF will be considered to be negative. Always remember this sign convention, students. So whenever we will solve any circuits regarding Kirchhoff's second law, we will be using these two sign conventions. Similarly, if I take resistance and current is flowing through the resistance, and if I take a direction which is along the direction of current flowing through the resistance, then that product of current and resistance will be positive. If I have taken a direction which is opposite to the direction of current along the resistance, then that product of current and resistance will be considered to be negative. So students, since we are dealing with EMF of cells and voltage of cells, so this law is in accordance with the law of conservation of energy, and it is also known as Kirchhoff's voltage law or KVL. So let me explain Kirchhoff's second law to you, taking an example. I have drawn a circuit here, students. So let me solve the circuit using KVL. So here there are two loops. This is loop 1 and this is loop 2. Let me first write the equation for loop 1 and write the equation for loop 2. Here, students, there are two EMFs. EMF 1, EMF 2, and there are three resistances. So students, here let me take loop 1. This is my closed loop 1. You can see in the closed loop 1 there are two resistances, R1 and R2, and there are two cells connected to that loop also, that is E1 and E2. You can see I1 current is flowing through R1 and I2 current is flowing through R2 along this direction in the circuit. Students, I have taken a direction, so I have considered a direction that is counterclockwise direction. If you want, you can also take clockwise direction. So I have taken a direction which is counterclockwise direction. So along my direction, if EMF is from minus to plus, along my direction is the direction which I have taken is from minus to plus, that EMF will be taken as positive. Along my direction, if EMF is plus to minus, then that EMF will be taken as negative. So there are two EMF in this first loop, students, and my direction for this EMF 1 is from minus to plus. So that means this EMF is positive. So for the first loop, I can write the equation. For the first loop, I can write the equation, that is the KVL law, that is total EMF should be equals to total product of current and resistance in that loop. So students, you can see here how many EMFs are there. There are two EMFs in the first loop. So the first loop and first EMF, my direction is from minus to plus. So this EMF E1 will be positive. So I am writing E1. And you can see along my direction if I go, and for the second cell or second EMF, my direction is from plus to minus of the second EMF. So this becomes negative, that is minus E2, because when I am going along my direction, the direction is showing from plus to minus, that's why the EMF is taken to be negative. So both the EMFs of the loops are written, of the loop is written, first loop. So let me now take the resistances. How many resistances are connected, students? There are 2 resistances connected in the first loop. So if I go along my direction and the current flowing along the resistance is also same. You can see I am going like this along my direction and the current is also flowing along the same direction. That means the product of I1 R1 is positive. So I can write I1 R1. But as I go along my direction and I come to R2, you can see the current is flowing in this direction and my direction is opposite to that of the current direction. That means the product of I2 R2 now needs to be negative. So I am writing it down, minus I2 R2. This is my equation 1 from the first loop. So this equation will help us find out the current inside the circuit. Similarly, let me take the second loop. So let me take my second loop. How many EMFs are connected to the second loop, students? Only one EMF is connected to the second loop and my direction is like this, the counterclockwise direction. Along my direction when I go, the EMF is from minus to plus. That means it is a positive EMF. So let me write it down. Summation of E is equals to summation of IR, which is equals to, so which is implying plus E1 is equals to, since no more EMFs are there in this loop, so I am taking only one EMF, that is my second EMF E2. E2 is in the second loop and which is also from minus to plus, so that is plus, is equals to, how many resistances are connected? There are 2 resistances, that is R2 and R3. So I2 current flows through R2 and what current flows from R3? So let us here apply junction rule. You can see here I1 current is coming and from here I2 current is coming. That means whatever current will leave will be equal to I1 plus I2. So the current will be here I1 plus I2. That means the current that is entering R3 is nothing but I1 plus I2. So total current along R3 will be I1 plus I2. So when I take my direction in the second loop, my direction is along the direction of current through R2. So that's why the product of I2 R2 will be positive. So I can write down I2 into R2. Now when I go along R3, I take my direction along R3. You can see my direction and the current direction is also same for R3. So here again the product of current and resistance will also be positive. So the current is I1 plus I2 flowing through R3. So this is my I1 plus I2 into R3. So this is what is Kirchhoff's law and how it is used, the KVL used in a circuit. So this is my second equation, students. So using the values of EMF and resistance given in our question, we can easily find out the current flowing through the circuit by using simultaneous equations. The more number of currents, that many number of equations will be required to solve the equations and to find out the current flowing through the circuit. So this can be used and we can easily solve for any complicated circuits, and we can use both the laws, the KCL and the KVL, to solve the complicated circuits. So this is what is Kirchhoff's first law and Kirchhoff's second law. So students, let us see another example and try to understand Kirchhoff's second law. So here I have taken 2 EMFs, E1 and E2, and 5 resistances R1, R2, R3, R4, R5 according to the given diagram. We have current directions also. So let me consider my direction. Let me take counterclockwise direction in the loop. So this is my first loop and this is my second loop. So you can see, students, I have taken my direction according to my own convenience. So we need to remember the sign conventions. The sign convention is that whenever our direction, that is we traverse from negative terminal to positive terminal of the cell, inside the cell or through the cell, then that EMF needs to be positive. And whenever we traverse from positive terminal to the negative terminal of the cell through the cell, then that EMF needs to be negative. Also, if our direction, that is we traverse along the direction of current through the resistance, then that product of current and resistance needs to be positive, and vice versa. So let me take both the loops, first loop and second loop. Let me solve first loop, students. So what is the first loop here? So how many EMFs are connected in the first loop? In the first loop there are two EMFs, that is E2 and this is E1. So if I traverse along anti-clockwise direction, I can see that my traverse direction is from minus to plus, that is this EMF is positive. And if I traverse from second EMF, that is from plus to minus, that means this EMF is negative for the first loop. So according to KVL, summation of EMF is equals to summation of product of current and resistance. And here I saw that the EMF 1 is positive and EMF 2 is negative. Now if I am traversing, if my direction is anti-clockwise, and if I take the direction of I1 R1, you can see, students, this direction and this direction is same. So I am going along this direction and the current is also going downwards. That means I1 R1 is also positive. So I am writing down I1 R1. So I am going along this direction, and you can see, students, the direction of current along R3 is opposite to my direction in the first loop. That's why it will be minus I3 R3. So if I take my direction now upwards and it is along I2, so this will be plus I2 R2. This is my equation number 1. Similarly, let me take the second loop and apply KVL. So if I take second loop, I have taken counterclockwise direction in the second loop also, and you can see when I take counterclockwise direction, the direction that I have traversed is nothing but from minus to plus of the cell, like this. That's why this EMF has been taken to be positive. EMF 2 is equals to. So how many resistances are there in the second loop? There are 3 resistances, R3, R4 and R5. So the counterclockwise direction which I have taken and the direction in the circuit is same. You can see the current in the circuit or the loop is same. So I can write down directly the product of I3 R3 to be positive. Similarly, my direction, current direction in the loop is same. So I4 R4 is positive. Similarly, I5 R5 is positive. So this is my equation number 2. By solving these two equations, equation 1 and equation 2, I can find out the currents flowing through each and every branch of the loops. So this is how we apply KVL in electrical circuits. Students, this is a question that you need to solve and find out I1, I2 and I3 flowing in the circuit.